Hello, I'm Brent Farris, and in this video I want to go over the Unity profiler. So we've gone over some Unity code before, we've done a bunch of projects, and one thing we haven't talked about is optimizing our code and going through it. So sometimes in my videos I don't use the most optimum code, I just use the code that's easiest to explain to get the point across. So let's go over some ways that we can check on optimizing our code or finding bottlenecks in our code. So I'm going to create a script called test, and we're going to start from there. Alright, so we are going to create a quick function inside a test. So we're going to start off with a private void start, and we're just going to do some function in here. We're going to do something like debug.log hello world. We're going to throw this onto an object inside of Unity. So let's open up Unity, and let's just go onto the main camera, and let's drop the script onto that. So when we press play, we're going to see the hello world get printed out here. So let's go ahead and I'll go over to our Windows, and let's go down to where we find the profiler, which is Control 7. What you're going to see is a bunch of stuff going on here, and it's just going to start spamming. If we click anywhere in here, it's going to pause Unity so that we can scrub and look at what's going on. We have a whole bunch of stuff here. We have network, physics, audio, memory, rendering. So the first thing that I want to look at, and the main thing that we're going to be mostly looking at a lot, is going to be the CPU usage. So you can see that there are spikes here in the CPU. I'm not doing anything, obviously, because my code just printed hello world on start. But we'll look at this sliver here. When we look here, we see that there's a wait for seconds, so we're waiting for our target frame rate here. The camera renderer is taking up 1%, there's only one call, there's garbage collection of 0 bytes, time milliseconds, so on and so forth. What you're going to want to use probably most of the time is the deep profiler. If you turn that on, you have to reload what's going on here. So let's stop and let's hit play. And as soon as it goes, you can see this is about where it started, this giant line here. And on that line, you can actually see our test.start. And in here, you can see the debug.log. Now, notice that the debug.log takes up about 31.7% of what's going on the CPU right here. And you may think that's a lot, but what really matters is the time in milliseconds. And the time in milliseconds is 5.58. So this is taking about 558 microseconds, so which is 5.58 milliseconds. And that is kind of a lot. And debug logs are kind of hefty because they interact with the engine and do printing and do stuff with strings and objects and all kinds of stuff. Now you can also notice that there is garbage collection going on here. So we have 9.4 kilobytes of garbage collection happening. We'll talk about garbage collection. We'll talk about a lot of this stuff throughout this video or the next one so that I can break these up. So let's make this video just about getting up the profiler, seeing how we can attach it with code, and in the next one we'll dig down into calls, and in the next one after that we'll talk about garbage collection, all that stuff. So you can see that we have our stuff logging here, and what we can do is that let's do a private void update, and here we're going to log out hello world. And let's not make it just spam it forever. Let's make a simple int temp equals 0, and we'll say if temp plus plus is equal to 5. Then we're going to print out hello world, and temp is going to go back to 0. So every 5 updates it'll fire off. So let's go back into Unity. Let's hit play. And now we're going to see this pattern here. Notice that in this one we have spikes. We have a spike here, spike here, spike here. We have a lot of these spikes that are happening on a lot of these. And if we drill down over here on the side, we can actually find our code. So you can see that here we have a behavior update, and it highlights this blue area. And we can see that it's taking 8 kilobytes of garbage collection. And if we open this up, we can see test we can see it's calling the update method in the test class, and it's calling debug log, and we can actually drill down in and see all the stuff that it's doing in debug log, but let's not get into that right now. We see our debug log is taking 8 kilobytes of garbage collection and 4 milliseconds. And if we scrub over to the left, we'll notice that this update isn't going to be very heavy. So on this line, here's the behavior update with the test update. Notice that 0 bytes of garbage collection, 0 milliseconds. So here, whenever we're not calling the debug log, you can see it moving around here. It's pretty good. And then whenever we hit those points when the debug log gets called, we're getting the garbage collection and the time in milliseconds. The time in milliseconds will never be constant. The operating system does a lot of stuff, and so that time in milliseconds will fluctuate because the operating system at that time your function was called could be managing a bunch of other programs. So it's actually going to slow down what's going to happen with your script. So this will actually never be perfect time in milliseconds. It'll be pretty close most of the time. They'll be relatively around the same speed, but you can't guarantee it's going to be the same. What you can pretty much guarantee, if you don't have a bunch of if statements and checks, is the garbage collection. The garbage collection is going to be constant on all of these spikes because we're calling the same function with the same parameters, so the same exact thing is happening. So we're going to have the same amount of garbage collection. Now, just to give a high overview, garbage collection is important because the more garbage collection we have, the slower that our CPU is going to be. And we want to reduce the garbage collection as much as possible, which sometimes puts heavier weight on our stack or on our RAM because you cache things into RAM so that they're living longer and not being collected all the time. And there's plenty of tutorials that go in depth about garbage collection. It's actually different for a lot of things. If you do C# versus Python, your garbage collection is going to be somewhat different. So there's plenty of resources to look up on those, and that would take up a pretty long video. So let's just talk about the basics of garbage collection, how we can see it affect in our scripts, and how we can cache to remove garbage collection. So that's it on the profiler setup, and in the next video we'll go over what these calls are. Notice there's only one call in this scenario. We'll go over what the call is and how it operates. So thanks for watching, and until next time, have a good one.